US Physics Olympiad, year 2014, USAPHO exam. For whole contest that were given 6 problems, Part A 4 problems, 90 minutes, and Part B, after a break, another 90 minutes for 2 problems. All solutions for all 6 problems you can find below this video in the reference of the description. Problem A1. A unicyclist of total height h goes around circular track of radius r while leaning inward at an angle theta to the vertical. The acceleration due to gravity is g. Question A. Suppose that h much less than r. What angular velocity omega must the unicyclist sustain? Question B. Now model the unicyclist as a uniform rod of length h, where h is less than r, but not neglectable. This refined model introduces a correction to the previous result. What is the new expression for the angular velocity omega? Assume that the rod remains in the plane formed by the vertical and the radial directions, and that r is measured from the center of the circle to the point of contact at the ground. Solution for question A. Here is the picture. We have a unicyclist in form of this red line, which is moving in a circle radius r. If we choose a frame of reference which is rotating around this axis with the angular speed omega, in this frame our unicyclist is stationary. We just need to solve a static problem. For static problem we need to equalize all horizontal and all vertical forces and equalize total torque to 0 around any axis. Let's do this. We have 4 forces acting on this unicyclist and this frame of reference. One force is a force of friction F, other force is a normal force N. Also we have a force of gravity mg applying to the center of this rod, and also we have fictitious centrifugal force mr omega square in this rotational frame of reference. As we can see, force of friction must be equal to this mr omega square. To equalize horizontal force, normal force must be equal to mg, and also we have torque around point of contact. We have counterclockwise torque from force of gravity and clockwise torque from this centrifugal force. Let's write this equation. It will be this one. On the left we have a torque from force of gravity, and on the right we have torque from this centrifugal force. Here we use knowledge that h much less than r. From this equation we can find that omega equal square root from g over r multiplied by tangent theta. That's the answer for question A. Let's do question B. Now, because we cannot neglect by height h of this unicyclist, we have to split him on little masses dm, and to count what is total torque we need to do integral. Now total torque created by centrifugal force will be this one, integral from r omega square z dm, where r is distance of this element dm from center of rotation, omega is angular velocity, z it's the height of this element above the ground, and dm it's a mass. Now we have to express our variables in this equation through variable which is distance from point of contact to our element dm. So from this point we have dm equal mass over total height multiplied by ds, z equal s cosine theta, that's a height, and r equal big R minus s sine theta, and the limits are from 0 to h. Using this variable s, we can express our torque by this integral. So finally this torque equal to this expression. And now we need to equalize it to torque created by force of gravity. Torque from force of gravity equal this expression, and now we can equalize them and find what is omega. And omega equal this expression. That's a solution for question B.